And first of all, happy Holi. Today we are going to do something really fun. Instead of just using GPT-2 like a normal user, we will dissect it and actually look what's happening inside it. Specifically, we are going to check how one attention head learns to recognize pattern, something called as an induction head. And I will explain everything as we go. So let's get started. Before we do anything, we need two tools. First, transformer lens. This is what lets us peek inside the model. Normally, GPT-2 gives you prediction. With this library, we can actually access the attention pattern and internal activations. Then we install circuit viz. Attention patterns are just huge matrices of numbers, and they are not very intuitive. So this library turns them into an interactive visualization. Let's run the block. Now you need to click run anyway. And if it asks for a restart, just restart the notebook so that everything loads properly. As you can see, a pop-up came to restart the session. I will only restart if I see there's a tick bar here. And as you can see, there's already a tick, and hence I will restart my session. After restarting, I think you have to run the code block again because every variables will be lost in that process. Now we move to the second block. Here we will be importing all the core libraries. First is PyTorch. PyTorch handles all the tensor math. Then we will be importing hook transformer from transformer lens. Hook transformer is a special variant of GPT-2 which lets us see inside what is happening under the hood. Like for example, we can see the activation and internal states of every attention head and attention layer and many other such things. Next we install or better say we are importing circuit viz. And in the next line, we are importing HTML so that we can render those visuals in the notebook. The next line is a checkpoint. Here we are checking if a GPU is available or not. If GPU is available, we will be training our model in the GPU. And if it is not, we will be training our model in the CPU. In the last line, we are loading GPT-2 Small onto our device. And mind you, GPT-2 Small is a 12-layer transformer. Each layer has multiple attention heads, and during training, different heads specialize into some different behavior. Now let's run the block. Okay, now let's move to the third block. Instead of feeding the model with an English text, we are going to create completely random tokens. And for that reason, I set the sequence length to 50. Then we will generate 50 random token IDs. These token IDs doesn't mean anything. They are just random integers within a vocabulary range. And then I concatenate the sequence with itself. So if a sequence is like A, B, C, D, E, the input sentence or the input sequence would be like A, B, C, D, E, A, B, C, D, E. The pattern is repeated exactly once. This is important because we are testing whether the model can recognize the repetition or not. So let's run the block now. Now it's time to move to the most important block of the entire notebook, that is the fourth block. Here we are running the model on this repeated sequence. Normally, if we run the model, we would get the logits. Now, what are logits? Logits are the raw prediction for the next token. But here I am using run with cache, which also stores everything that is happening inside the model during the forward pass. So we get both the output and the internal pattern of the attention heads. Now I initialize layer and head equal to 5. Some of you may have doubts like why did I set or why did I initialize with 5? Well, researchers at Anthropic realized that, or they found out that the head number 5 in layer 5 works as an induction head. So we will maximize or zoom our focus into that particular head to gain or to see the attention pattern. In the next step, in the next code, we are extracting the attention pattern for that specific head from the cache memory. This attention matrix tells us for every token in the sequence which previous token it was looking at. Next line, we are converting the token IDs into readable string tokens, so the visualization makes sense. Then I pass the attention matrix into circuit viz to create an interactive heat map. And then finally we will render it using HTML. Now let's run it. Okay, so the model has generated the output. Let's see the output. Let's zoom into this graph. Alright, now you can look at this grid. The x-axis are the tokens doing the attending part, and the y-axis are the token being attended to. Brighter the color means stronger the attention. You can also see some light dull colors here, and you should see a bright diagonal line. What does this diagonal line means? When token A1 appears again in the second half, it strongly attends back to where A1 first appeared. Similarly, when token A2 appears again, it attends back to its first occurrence. So this head has basically learned sequence repeating, and it is using the earlier occurrence to inform what comes next. This behavior is called as an induction, and this mechanism is one of the foundation of in-context learning in transformers. Now the model has also outputted given a sequence. So let's see. If I point my cursor to the token during, the induction head will point to the token house. And similarly, if I move my cursor to information, the induction head will point towards game. So what we just did was take a pre-trained GPT-2 model, generate a repeated random sequence, run it while storing the internal activation, extract that one specific attention head, and visualize its behavior. And we saw clearly that it learned a reusable pattern recognition algorithm purely from the next token prediction training. There were no explicit rules that were coded in this notebook. The pattern recognition emerged during the training, and that's honestly one of the coolest things about the transformers. So that's it from today. Happy Holi again, and thanks for watching.